Hello everyone and welcome to this video lecture.
Here's the second question. In the second question, we need to write the algorithm or the flowchart for the following data in the table. The data contains the table of two floating point numbers, and we need to calculate the algorithm or the flowchart for subtraction of these two algorithms. Secondly, we need to calculate the multiplication of these two numbers, algorithm for these two numbers, and in third, we need to find the algorithm for division of these two numbers. So first, let's draw the flowchart and the algorithm for the subtraction part. Here's the flowchart for the subtraction of the two numbers n1 and n2. The algorithms are also the same. So what we have done here is we have read the values of n1 and n2. The n1 contains the value n1 and e1. M1 is the mantissa part and e1 is the exponent part. And in N2, the M2 is the mantissa part and E2 is the exponent part. And then we check the condition of E1 equals E2. If E1 is equal E2, then what we do is we just simply add the mantissa part and the exponent part, and the exponent part is either of E1 or E2, as it makes no difference as both of them are the same. And we check if the result we get after adding m1 and m2 and e1, that it is normalized or not. If the condition is normal, if the answer is normalized, then we simply print m comma e and then stop the algorithm. But if the condition is not normalized, then we need to normalize the result. How normalization is done is we make the exponent part of both the expressions same by shifting the decimal part and increasing the exponent part. The greater exponent remains the same, and the smaller exponent is increased by shifting the decimal part in the mantissa place. And then we check the exponent part. If the exponent part is greater than 99, it is the overflow condition. In the overflow condition occurs where as the exponent part cannot store more value than 99, so it shows the overflow part. And if this condition is not true, we check for the underflow part. And if both the conditions are not are met, then if both the condition, the overflow part and the underflow part are not met, we go over here and we print, and we go over here to the A part. That is from here, we go over here, and then the condition is normalized, and then we print the result. This is the this was this the left this LHS part was just for when E1 and E2 are the same, that is the exponent part of both the numbers are same, we perform this following step. Now we're gonna check if the E1 and E2 part are not same. In that case, if E1 is if even greater than E2, we check the condition E1 is greater than E2 or not. If E1 is greater than E2, we shift the mantissa of E2 by difference of E1 minus E2. And then we add the mantissa part and the even part, then the exponent part is of E1. And if E1 is not greater than E2, we shift the exponent part by we shift the mantissa of E1 by E2 by E1, and then the mantissa is added M1 plus M2, and the exponent part is E2. And afterwards we go over to the A condition, that is over here and then over here. And afterwards we check the normalization part, and if the required result is normalized or not. If not normalized, we normalize it and print, and then we print the result. This is the flow chart and the algorithm for calculation of subtraction of two floating point numbers. Now let's check the multiplication of two floating point numbers algorithm and the flowchart. This is the algorithm, this is the flowchart for calculation of multiplication of two floating point numbers. as similar to the subtraction part, here we have firstly read the values of n1 and n2, which contains m1 and e1 as their mantissa and exponent part of n1, and m2 and e2 as exponent parts and exponent and mantissa part of n2. What we do here is we just simply multiply the mantissa part m1 and n2, and the exponent part are just get add e1 plus e2. Unlike in subtraction where the either of one of them is selected, here we add the mantissa part and then we check for the normalization part. If the condition is normalized, we simply print the m comma e part and stop the result. And if the condition is not normalized, we check for the condition that if it is normalized or not. If and check for the overflow and the underflow conditions. If if the exponent is greater than 999, then we print the overflow condition, and if not and less than 99, then we print the underflow condition, and then we move to again to the part A, that is over here, and then we check again if the condition is normalized, then it would be normalized, so we print the result. This is the algorithm for multiplication of two floating point numbers. Now let's check the algorithm for division of two floating point numbers. This is the algorithm for division of two, no, two division of two floating point numbers. Similarly, we firstly read the values of n1 and n2 containing the mantissa part as n1 and e1, and in second n2 we have the values n2 and e2 as the mantissa and exponent part. What we do here is the mantissa parts becomes n1 divided by n2, m2, and the exponent part becomes mod of e1 minus e2. And we check for the condition of normalization similar to the multiplication step. And everything here remains same as to the multiplication. If the result is normalized, we print it. Otherwise, and if otherwise, then otherwise we normalize the result by shifting the decimal part and making the exponent part same. And if the exponent is greater than 999, we print the overflow condition. And if it is less than 99, we print the underflow condition. And afterwards we go again back to this case and check if the condition is normalized. This time it would be normalized, so we print the result. So this was the algorithms and the flowchart for the three step, and we look to the table over here. As we have looked, the datas over here are given n1 and n2 and n2 and n3, and by the procedure of the following subtraction algorithm, we found here the result as 0.028 and the exponent part is 99, and it is in the underflow condition. And for data 2, the result is 0.2800 and the exponent is 1. It does not show any error, as here there is no error over here. For the multiplication part, it's in overflow condition and the result is over here. And for the data 2, the multiplication is over here and the error message is over here. Division, similar to multiplication, we have also seen the division algorithm. From that we have concluded this result. The n1 part, the n1 and n2 part over here are given. So the result over here is 0.9998 and exponent part is 101, and it is in overflow condition. And for the data 2, it is 0.9998 and the exponent part is 104 and it's in the underflow condition. So this concludes the question number 2.